Oh, yeah, actually, so I heard that overall the average on the test was pretty good compared to previous years. So sounds like y'all did a good job. So good job on that. Um, what did y'all think about it?
I thought the test was pretty easy. Did you?
For digital logic, I always think I do better than I actually did.
Oh yeah.
I'm always like, yeah, I aced it, and then I really got like a B. So,
It's not terrible.
I thought I got an A.
Yeah, that is disappointing when you think you did really well, like when you think you really aced it. Yeah. So yeah, but he was pleased and said that y'all seemed to. He said either. But did you find that it was close to what? Close to like the review that I did?
Yeah. I don't remember specifically.
Well, it looked to me, the test looked like the same, that it similar to how it always is. Okay, so here is the lab that y'all are going to do tomorrow. And this is similar to labs from previous years. It's similar to labs in digital logic everywhere. A vending machine is a very common project to do. And so this one, you are supposed to have a that's the wrong one. You are supposed to have a vending machine, and the vending machine has several different inputs that it can take. It can take either nothing, or 5 cents, or 10 cents, or 25 cents. And then as soon as it gets 20 cents, it's supposed to dispense water. It can also give change, and the change it can give is 5 cents or 10 cents. So finally, I have the directions here. Okay, so design a Moore type state diagram. Outputs depend on current state only. To implement the system below, the system has 3 inputs and 2 outputs. So your inputs are A and B that determine whether how much you received, 5 cents, 10 cents, 25 cents, or no coin. Also, the clock is your third input. And your output describes its action. Dispense a water, give 5 cents change, give 10 cents change, or do nothing. You need to understand that when it says gives 5 cents change or 10 cents change, it also is dispensing the water. So like if you put in a quarter, you get 5 cents change and the water. That's not, that's kind of built in there. The price of the water is 20 cents. Dispenses water as soon as it has received 20 cents or more. If the amount received exceeds 20 cents, then return the correct change to the customer. Okay, so there's a little hitch in there that was pointed out to me a couple years ago, and I have the same thing in the one that I designed, so that you will have to see. I thought I downloaded it. Have to see how you are going to interpret it. So it's your design, so you can interpret. I think you can interpret things your own way. It does depend on your TA. But what I did was early this morning, I said, what can I do to make something similar but not the same? So congratulations, you have a new job working for a company that produces vending machines for airports. Your first task is to design a vending machine for selling Bluetooth earbuds. You are supposed to write Verilog code for a Moore machine. You are told that the machine can accept $5, $10, and $20, and can give $5 or $10 change. The earbuds cost $35, and the machine should dispense the earbuds as soon as it received at least 35. Other than those specifications, you are free to design the machine as you wish. Okay, so let's take a look at this and determine what what the 4 possible inputs are. So what are the 4 possible inputs?
The clock, and then the 10, the 20, the 5.
Okay, so you're answering a different question than I meant. I'll come back and put that in. What I meant here, but that's not wrong. But what I meant was you could input $0, $5, $10, or $20. And the question that you answered was your inputs would be the clock plus how many bits do you need to represent these four inputs? You would need 2. So you would need 2 other values. We'll just call them A and B. We'll come back to that. So what are the 4 possible outputs? Okay, so let's say you put nothing in. What's your output? Nothing. What's your output if you just put one $20 bill in? Nothing. What's your output if you put in a $20 bill and then another $20 bill?
$5 in
Yeah. So that would be you get $5 change plus earbuds. What if you put in a $20 bill and then a $10 bill and then a $5 bill? Just earbuds. And what if you put in a $10 bill, a $5 bill, I'm sorry, you put in a $20 bill, a $5 bill, and then another $20 bill.
$10.
You get $10 plus earbuds. Okay, so now we're going to assign binary values to our answers for 1 and 2. We're just going to do this the same way so that we all have the same code, but if you were designing this on your own, you could do it however you wanted. For your lab, you have to use the specifications here. You have to do these are going to define your inputs and outputs. But I'm going to do A and B will be our inputs. And I'll have 0, 0 is $0 input. 0, 1 would be $5. 1, 0 would be $10. And 1, 1 would be $20. And then for our outputs, I call them C and D. I had 0, 0 was do nothing, or no change, I think is what I ended up calling it, no change. Let's see, how did I do it? Um, 0, 1 was earbuds. One, 0 was earbuds plus $5. And 1, 1 was earbuds plus $10. Okay, so this one is gonna have a lot of states. It'll have more states than the one that you have to do, but in some ways it's easier, as we'll see in a minute. And so, some states are easy, so, I put the easy ones on here, that you can easily see how you could get to a state where you had $5, that's if you input 5. A state where you had 10, you could either input a 10 or input 2 5s. 15 would be a 10 and a 5, 20, 25, 30, all of those. And so, how many states did I come up here that are like kind of the straightforward states? How many states is that altogether? Y'all can count. Yeah. It's A through J.
Oh, 10.
10. Okay, so how many bits do we need?
We need 4.
4. And why 4 is correct, and why 4?
Because you can 3 fifths is 7.
So 3 would get us 8 states, and then 4 would get us 16. So we have to have 4. So let's just assign these in order so that we all have the same thing. So 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. I know it's so hard. 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, and 1, 0, 0, 1. Okay, so y'all do this on your own. What is the progression of states? So I'll do one first. So what is the progressions of states? I'm going to say if you insert, let's say you insert 20 and a 10 and then a 10. So the progression of states would be E. You have a $20 balance, and then after you put in 10, it would be G, and then after you put in another 10, it would be I, because it will have given you your change, so you have like $0 left in the machine, and you will have gotten your $5 change. Okay, so I would like y'all to do number 5, A through E, on your own, and say what would your progression of states be in each of those instances. Oh, I guess I did C. That was C right there. Okay, so two $20 bills. What did y'all get?
EI.
E and I. Okay, a 20, a 10, and a 5.
EGH.
EGH. A 20, a 10, and a 10, I did that. A 5, a 20, and a 20.
Oh, do we have to specify we start at state A each time?
It's not, yeah, probably so, yeah.
Sideways.
Okay, so A, whoops, A, E, I, G. Okay, so D, you start at A, and then what's the next state? For a 5, a 20, and a 20?
ABFJ.
A, B, F, and J. And then four $10 bills.
A, C, E, G,
A, C, E, G, I. Yep. Okay. What if someone inserts a $20 bill, and then a $10 bill, and then a $20 bill? So this person has put in $50, but there's not the option of giving $15 change. You could treat this in several ways. You could say the machine says that it only gives $5 or $10 change, so this person should have put in the two $20 first, and then treat it with don't cares. And say, I don't care, you didn't follow the rules. Well, whatever happens, that's, you might not get anything. It's your problem. Yeah. Okay, so you could do that. You could also say that, well, it says it only gives $5 or $10 change. They put in 50. We'll give them $10. That's it. They just lose the 5. I win. Okay, so you could do that. Or you could say that we'll give them $10 change, and they'll keep the $5 balance in case they want to make another purchase, because maybe this machine has other wonderful things in it as well. I don't know. So if you choose the first option, then all you have to do when you would set up your state diagram is to treat it with don't cares. If you choose the second option, all you have to do is when they put in $50, you just have to send it to the state where it gives $10 change. But if you choose the third option, you would need an additional state. So what additional state would we need if we say, we'll give them $10, but let them keep $5 in the machine towards the next purchase? So we'll need to have a new state. We can call it K. And how could we describe that?
earbuds plus 10 plus 5 credit.
Yeah, earbuds plus $10 change plus $5 credit. All right, so now we're going to draw a state diagram for this machine, and we'll show how you would modify it for the different designs. Okay, so was this a melee or a more?
More.
This is more.
I was,
So the instruction said for more.
Did you read the title?
yeah, that's what we're supposed to do.
Yeah, but I think she was like asking like prior knowledge.
What the instruction said or prior knowledge?
I don't know what I wanted. How many states total do we have now? 11? If we do all?
Yeah, 11.
11.
Okay.
Okay. So,
Switch
It falls like a
Yeah,
jam.
I see,
Smaller.
I mean, this is something expensive. Now,
Maybe $5 for the convenience.
I'm not doing that.
Gold, maybe $4, and I'm good. Make it $5.
I'll give you $1.
I'll give you earbuds
Okay, no one can meet
and
out.
$5 change.
Whoa. Pretty good.
I'll choose
Can't beat that.
credits.
I'll give you
Narrow
$5.
something.
Yeah, I'll give you $2 credit to a,
That's kind of weird how it's giving credit for like an earbud machine. Like they're cheap and they expect you to break them.
I want to check on cars now. I don't know.
brother, you need a bulk up.
So let's see, after $30, you would either get earbuds or you could get $5 change, or you could get $10 change, or we decided this is an option. You could have $10 change plus $5 credit. Okay, so the way you want to do this design, and this is the same thing you're going to want to do on your lab, is you want to think about for each of these states what happens for your 4 possible different inputs. I think it's kind of easiest just to do them by color because then you don't have to write on it. So I will have green be no coin. So that way I don't have to write 0, 0 on each one. I know, or it wasn't 0, 0, it was no coin. For me it was 0, 0. On your lab I think it's something different. And so for most of these, not putting, or no, what did I say, do nothing? I said do nothing. So do nothing is you don't put anything in. So this is do nothing. For most of them, you'll stay at the state where you are, but not for all of them. So as I'm drawing this in for most of them, which states would you not stay where you were if you do nothing? Okay, so let's say you're at the state where you got dispensed earbuds and you don't put any coin in. Next clock cycle, are you going to get a new pair of earbuds? No. So where should you go if you do nothing and you got dispensed a pair of earbuds?
No change.
Go back to no change. Okay, what about if you got $5 change? This is the machine I want, the one that stays at itself if you do nothing, that just keeps shooting out $5 bills at you. But that's not going to happen, so you go back to no change. $10 change is also going to go back to no change. What about $10 change and $5 credit? Where is that going to go to?
Also no change.
Not no change, because you have $5 credit. It's going to go back to the same state as if you had put in $5. Okay, so now let's do what happens if you put in $5. So for each state, what happens if you put in $5?
Where's the next? That's it.
It's going to go to the next $5 one. Okay, what's going to happen from the earbud state if you put in $5? So you
No change.
not, no, because $5 change also gives you earbuds. And $10 change also gives you earbuds. Nope, it's gonna go to $5 credit, or that you've put $5 in. You bought your earbuds, you got them, you're gonna buy some more, you put another $5 in. Okay, what about if you are at you got $5 change in earbuds, and then you put $5 in? Go back to 5. $10 change in earbuds, and you put $5 in? Yep. $10 change plus $5 credit, and you put $5 in. $10. Okay, now let's put in $10. So from no change, you would go to $10. From $5, you would go to 15. From 10, you would go to 20. From 15, you would go to 25. From 20, you would go to 30. From 25, you would go to earbuds. Where are you going to go from 30 if you put $10 in? So you have $30 already in the machine, you put $10 more in. $5 change. Okay, so you've already put $30 in, so it's got $30. You put in another 10, so you've put in a total of 40. You've put in at least 35, so it's going to dispense earbuds, but you put in $5 too much, so it gives you $5 change. Okay, if you got earbuds already and you put in another $10, where are you going to go? $10. And the same for the $5 change and $10 change place. If you put in $10, you'll go to $10. What about the $10 change plus $5 credit if you put in $10? Okay, so you put in enough money and it gave you change, you got your earbuds, and it has $5 credit in there. And you put in $10 more, 15. Okay, last but not least, what happens if you put in $20? From no change, you'll go straight to 20. From $5, you'll go to 25. From 10, you'll go to 30. From 15, you'd go to earbuds. From 20, you'd go to $5 change. From 25, you'd go to $10 change. And from 30, you'd go to $10 change plus $5 credit. And then from earbuds, $5 change and $10 change, you would go to 20. So now this last one, if you're at $10 change plus $5 credit and you put in 20, where are you going to go? It's got $5 credit and you put in 20, 25. Okay, now how would this change if we didn't have this last state right here? How many things are going to that state? How many are going to this state right here? Just one. So if we got rid of this state, all we'd have to do is decide what do we do with this arrow. So if you have $30 and you put in 20, you would say either don't care, or you would say you're just going to this state, or you're going to this state, or whatever you want to do with it. Now, let's see, how does this apply to your lab? So what are the states on your lab? So you can put in no coin, you can put in 5 cents, you can put in 10 cents, or you can put in 25 cents. And you can you can get nothing, so it would be nothing, just a water plus 5 cents, and a water plus 10 cents. I'm gonna pause this. I'm gonna give y'all just a few minutes to see if you can come up with the state diagram that you have to do for your pre-lab anyway, and then see if you have any questions on that. Okay, so you do have to have the state diagram for your pre-lab. You have some freedom, such as, what do you do for the things that aren't specified here? So like, it doesn't tell you what to do in certain situations, and I would say that you decide for yourself, but I'm not the one grading it. So, but these are the inputs, and that's what you'll need to know for doing your coding. You don't really need to know it for your state diagram. Okay, so the basic idea is that if you're at any of the states where you've put in some money but have not gotten any water yet, if you do nothing, you should just return to where you are. If you're at one of the states where you've gotten water, or if you've gotten water and change, then you should go back to the reset if you do nothing. And then the next thing that you can do is you could add 5 cents. So it's easy to see what to do if you add 5 cents. If you're starting at one of the ones that already has money, you're just going to go to the next state that has 5 more cents. So from reset, you go to 5, 5, 10, 10, 15, 15, you go to getting water. But if you're at one of the states where you've dispensed water, then you've reached the end of the cycle. So if you put 5 more cents in, you should go back to the state of putting 5 cents in. So from any of those, you should go back to 5 cents. Similar sort of thing will happen with 10 cents. If you're at one of the money states, you should go ahead. So from reset, you'd go to 10. From 10, you'd go to 15. From 5, you'd go to 15. From 10, you'd go to dispense water. If you have 15 and you put in 10, that means you've put in a total of 25. So you should go to water plus 5 cents change. But if you're at any of the ones that you've already gotten the water, if you put in 10 cents, you should go to your 10 cent state. The fun happens with 20 cents. So from reset, if you put in 20 cents, you'll go straight, 25. From reset, if you put in 25 cents, you'll go straight to water plus 5 cents change. From 5 cents, if you put in 25, you go to water plus 10 cents change. From 10 cents, if you put in 25, you've put in 15 too much. We don't have a state for that. So we'll come back to that. If you've put in 15 and you put in 25, you've put in 20 too much? 15 plus 25, yeah. Now, with these other states, water and the change states, if you put in 25, you would go to give water and 5 cents change. So now it's up to you to decide what you want to do with these. You could make these arrows, these arrows correspond to putting in 25 cents. You could make those don't cares. You should say Don't care, nobody should ever do that. That's stupid. Why would you put in, if you have a quarter, why would you put in 10 cents and then put in a quarter? Why wouldn't you just put in the quarter? You could say, I'll just give 10 cents change, that's it, they've lost the rest, and you could just send them straight to the 10-cent state. Or you could make 2 more states. You could have give water plus 10 cents change, and then have 5-cent balance. And you could have give water plus 10 cents change, and have a 10-cent balance. And then you can figure out what to do for those. How do you think those would react? How do you think those would act? You'd have to put all 4 different inputs onto them. So what's going to happen for each of these if you do nothing?
Back to 0.
Not to 0, because you have a balance.
Oh, you back to 5.
So this one would go to your 5-cent state, and this one would go to your 10-cent state. And then after that, they would act like the 5-cent and 10-cent state for the different inputs. Okay. So let's go back to the worksheet. All right. We did that. Consider the code for the third design, the one that keeps the balance, shown on pages 4 through 6. Does it work as intended? Explain the overall structure of the code. Believe it or not, it only took me 15 minutes to write this code. Copying and pasting save a lot of time. So I did. I wrote this morning. I tested it. It worked. And I now see that there's a better way that I could have done it. Let me grab it and put it all in Notepad++. What type of machine did we say this was? More. So what does the output depend on? Just the state. And if you look the way I have it done, I have a little bit of too much extra in there. It's not necessary. So then now we're back to the earbuds, but it's just going to be the same idea. Is it just not opening? That's what happens when you have a million things open. I forgot to do the QR code. Would someone make, let me do the QR code real quick. I say I'll do the QR code real quick. Okay, can y'all get that?
If he's entering in his ID, does he have to like rescan it again? Or like the QR code, I mean?
Does he have to?
Yeah, as in will him putting in his number after mine,
No, it should be okay.
Yeah, I'll do that.
so
Right.
Okay, so keep in mind, especially anyone who is like just looking at this video, this is not the code for yours. This is similar but not the same. It uses 5, 10, and 20 and not 5, 10, and 25, and it detects 35 and not 20. So you don't want to use this exact code, but you can model it, and then I also came up with something that will make it a little better.
Have you found it's easier to like copy it in the notes and then into the software? Because it always seems
Some-
like change
yeah.
up the capitalizations or something.
Well, it depends. If I do Notepad++, it usually works pretty good. I actually usually do type it straight into Viveda, though. There we go. Now I got it. Okay, so here's Notepad++. And here is the code. But yes, it will often mess it up. But if you go through Notepad++ first, a lot of times it can fix some of the things that are messed up with it. Okay, so if you look at what I did here, I named each of my states with names that made sense to me. because this way, when I'm putting in what the next state is, I can think about it. And like rather than having A, B, C, D, I know that if it says have 15, I know that if I put in 5, that I'm going to go to have 20. And so I gave so in this case, I did use the parameters, and I even put in parameters for my inputs and my outputs, not just my states, but my inputs and my outputs. So notice my inputs were A and B, and then I gave those parameters names as well. So do nothing, insert 5, insert 10, insert 20. And so for yours, it'd be do nothing, 5 cents, 10 cents, 25 cents. And then my outputs, no change, earbuds, change 5, change 10. Yours would be no change, water, 5 cents change, 10 cents change, and so forth. And then I put in a little initial block to set it to initially be at reset and no change. But if you notice, what I did that was not clever is I have for each state, yeah, it sometimes does that. Everybody okay? Yeah. Okay. So for each state, it says what the next state is based on the input. It also says, actually no, I guess this works because it's giving you the output. It's giving you the output that goes with that next state. So that's okay. So never mind, it works. Okay, so it gives you the next state and what the output is that goes to the next state. And so when I put this in, the way I typed it in is I started like this. So always at current state or my inputs. And then I'm just going to have a single case statement. So case, and the case is going to be based on my current state. And then I'm going to list what my states are. So whatever your states are, reset, have 5, have 10, have 15, dispense, water, water, and 5 cents, water, and 10 cents. And then if you have any additional states, you could put those in. And then to save time, what you can do is just put in, you're going to have another case statement for each one of these. So this is going to be the case based on your inputs, case A, B, so you put A, B together. And then I gave mine names. You don't have to give them names. You could have 2B00, 2B01, 2B10, 2B11. And these correspond to,
Oh, your screen sharing is paused.
yeah, but there's nobody on Zoom anyway, so. But thank you for telling me. But at least I don't think there's anybody on Zoom.
I thought that's how it was recorded.
No, it's recording with this one up here. So that's the one that records that I make for YouTube. So on yours, which I seem to have closed, those inputs correspond to so 0, 0 is received 5 cents, 0, 1 is received 10 cents, 1, 0 is received 25 cents, and 1, 1 is no coin. Okay, so once you have that, for each one of these, you would have a begin, and an end. And you would have next state becomes equal to something, and you would have your output becomes equal to something. So you'll have that for each one of these. And then you would have an end case. And then you can copy this to each one of your cases. And then you just go through and look at your state diagram and you say, well, what happens for each one of these? And then you'll end your outside case. And then you'll have your second always block, which would be always at positive edge of the clock. This one you'll need a begin and an end because you're going to tell it two different things. You're going to tell it that the current state becomes equal to the next state. Oh wait, sorry, all of these CDs should have been next output. You can do this in Vivato, by the way, as well. So current state becomes equal to next state, and then CD becomes equal to next output. All of these should have semicolons at the end of them. End and end module. And so once you fill all those in, it should work. My little example with the earbuds worked just fine, so I tested it. So I'm going to have to, well, we have time. So explain the following cases: reset, have 20, dispense, give 10. So let's just look at some of these cases and see how they make sense. Okay, so let's look at the reset case. Explain this one. How does that one work? First of all, what are A and B?
Those are the two two inputs telling us which interaction occurred?
Those are the switches, and here is where I gave names to those different values, so I could refer to them by name and not by the binary number, so that I could remember, especially because y'all's are kind of weird, that like 1 is insert nothing, insert nothing. So A, B are the two switches, and then these are the 4 different values that it can have. And then do the next states and the next outputs make sense? Yeah? All right, so let's look at the have 10 over here. Remember, this is for the earbuds, and you have to have 35 to get earbuds. So is there any way that you could have 10 and then input enough to get to 35? If you can only input a 5, 10, or 20?
No.
No. So for these, the next output is always going to be no change, because you can't get earbuds. And so if you have 10, then if you do nothing, you have 10. If you insert 5, you have 15. If you insert 10, you have 20. If you insert 20, you have 30. Okay, so let's look at the have 20. Let's look at the have 20 case. Does that one make sense? Yeah, explain that last one, the insert 20. Anyone? You are the one nodding. Most of the people are sleeping, so. But anyone?
Oh, yeah.
So if you input 20 whenever you already have 20, you get yourself 40, which means you pay 35 and get 5 back, as well as the headphones, which it doesn't actually say give headphones, it just says change 5. But I'm guessing that's like implicit.
Right. It means give headphones and give $5 change.
So, by the way, since we're going to put ourselves to the state of change 5, I'm just thinking, is it, because each one of these executions seems to be,
This is,
whenever I see do nothing, I imagine the person pressing a button, like pressing the button to read the change or something. It's like you input a $20, you press the button to read the $20, and then there's do nothing because you can press the button without having quick change in there or money in there.
mm-hmm.
But is the do nothing also supposed to be like basically you get to the change 5 state, and the moment you hit the change 5 state, you ignore input to spit out the money, and then you go back to a do nothing state, or the have 0.
So do nothing is not a state. A do nothing just means you put in $0.
Right.
So, but the answer to, I think, to your question is once you have given change, if you don't put in money, you go back to the reset state.
Automatically.
Right. Now, could I at this point have done next state is reset, next output give change? Yes, but that would have made it a melee machine. So it wouldn't really have been next output, it would have been output give change. So the output would have been give change, and the next state would have been reset. So I wouldn't have had to have done a next output. This is really saying that my output for the give 5 state is to give 5 cents change. Because if I look at my give 5 state, I didn't actually do this in necessarily the best way, but it does work. So if you look at the give 5 state, its next states are exactly the same as the reset state. The only difference is with give 5, you output 5 cents change. But the direction said more, and so that's why we're doing the state and the output together.
Alright. So is our level more, the one we're doing?
Yes.
Okay.
And then these are the constraints that I used. You can probably use the same constraints if you want. This is that little extra button clock or button panel that I put on there. And so these are the two rightmost switches and the two leftmost LEDs. So are there any questions? All right, I have a good feeling about this one. Every week I have a good feeling, and then the next time I see y'all, you're like, oh, nobody finished. But this time I really have a good feeling about it.